Chemical reactions and equations. What is a chemical equation? A chemical equation is a symbolic representation of a chemical reaction. Any substance that is used up in a reaction is a reactant, and any substance that is produced is a product. A reaction can have one or more reactants and one or more products. The four basic chemical equations are represented here. Chemical equations. A chemical equation is a shorthand representation of a chemical reaction. The reactions are on the left. The products are on the right, and an arrow represents the reaction. For example, reaction of hydrogen with oxygen yields water. An equation would represent this reaction as shown here. The equation would be read as hydrogen plus oxygen yields water. The arrow can be read as produces, or becomes, or yields. The plus sign on the left side of the equation means that hydrogen H and oxygen O are reacting. The arrow head points towards the products and shows the direction of the reaction. Writing a chemical equation. A chemical equation may look like a mathematical equation, but it describes experimental observations. Reactants appear on the left-hand side of a chemical equation, while products appear on the right. The products which result out of combining the reactants are known from experimental observations. They cannot be derived mathematically. Writing a chemical equation. Word equations such as water produces hydrogen and oxygen when electrolyzed can be informative. However, skeleton equations in which chemical formulae are substituted for the chemical names are even more useful. Skeleton equations are sometimes called unbalanced equations. A skeleton equation for electrolysis of water is shown here. The formula for water is H2O. The formula for hydrogen is H2. And the formula for oxygen is O2. A skeleton equation is just a representation using the formulae to indicate the chemicals that were involved in the chemical reaction. Writing a chemical equation. Take a look at the symbols that are used in chemical equations. Law of conservation of mass. According to the law of conservation of mass, a chemical equation must be balanced. This means that the total number of atoms on the reactant side must be equal to the total number of atoms on the product side. This really involves three skills: interpreting a chemical formula, determining whether or not a chemical equation is balanced, and balancing the equation. Balancing chemical equations. The steps involved in balancing a chemical equation are stated here. Begin by writing the word equation. Write the correct formula for reactants and products involved in the reaction. Find the number of atoms for each element on the left side. Compare those against the number of atoms of the same element on the right side. Determine where to place the coefficients in front of the formulae so that the left side has the same number of atoms as the right side for each element in order to balance the equation. Check your answer to make sure that the number of atoms on both sides of the equation are now equally balanced. The coefficients are in the lowest possible whole number ratios. Balanced chemical equations. Examples are shown here to balance chemical equations. Observe carefully and understand the steps involved in balancing the equations. Types of chemical reactions. Chemical reactions may be classified in different ways. Some examples of widely used terms for describing common kinds of reactions are combination reaction, decomposition reaction, displacement reaction, double displacement reaction. Combination reaction. The general representation for a combination reaction is A plus B produces AB. A combination reaction involves two or more substances combining to form a more complex product. The reactants may be elements or compounds, and the product will always be a compound. Some of the examples for combination reaction are formation of water from hydrogen gas H2 and oxygen gas O2. Burning of coal and oxygen to give carbon dioxide and calcium oxide CaO, reacting vigorously with water to produce slake lime, calcium hydroxide. Decomposition reaction. The general formula for decomposition reaction is AB produces A plus B. In a decomposition reaction, one substance is broken down into two or more simpler substances. This type of reaction is the opposite of a combination reaction. Study and understand the examples carefully. Displacement reaction. Displacement reaction can be represented as, in the case of a positive ion being replaced, A plus BC yields B plus AC, or in the case of a negative ion being replaced, A plus BC yields C plus BA. In either case, we have element plus compound producing element plus compound. Some examples of single displacement reactions are shown here. Go through the examples carefully. Double displacement reaction. The basic form of double displacement reaction is AB plus CD yields CB plus AD. Like dancing couples, The compounds in a double displacement reaction exchange partners. Take a look at the examples carefully. Oxidation and reduction. The term oxidation was originally used to describe reactions in which an element combines with oxygen. The reaction between magnesium metal and oxygen to form magnesium oxide involves the oxidation of magnesium. The term reduction comes from the Latin stem meaning to lead back. Anything that leads back to magnesium metal therefore involves reduction. An example is the reduction of magnesium oxide to magnesium metal by heating with carbon at 200 degrees Celsius. Carbon monoxide is the oxidized product formed. Because electrons are neither created nor destroyed in a chemical reaction, oxidation and reduction are linked. It is impossible to have one without the other, as shown here. Effects of oxidation reactions in everyday life. Corrosion, rusting of iron, fueling the space shuttle, the environment and human health, photosynthesis, oxidation, spoiling and aging, browning of apple, electrochemistry and batteries. Some important effects of oxidation reactions in everyday life include corrosion, fueling a space shuttle, cellular respiration and decay or aging of food. Oxidation may also be linked with the effects of aging in humans, as well as with other conditions such as cancer, hardening of the arteries, and rheumatoid arthritis. Oxidation reduction reactions also play a major role in electrochemistry. Rancidity. Keeping foods in airtight containers helps to slow down oxidation. The deterioration of fats and oils due to exposure to light or heat leads to a condition characterized by a stale, unpleasant taste and smell. What we perceive is an unpleasant change in the flavor and odor of a food is called rancidity. The most important cause of deterioration in fats and fatty foods is oxidation. Oxidation of fats results in the replacement of an oxygen ion for a hydrogen ion in the fatty acid molecule. This substitution destabilizes the molecule and makes it possible for other odd chemical fragments to find a place along the chain. Keeping food in airtight containers helps to slow down oxidation.